There are a few different transformations of parabolas, and we're going to look at them by comparing them to a simple parabola, y equals x squared. So for this first transformation, dilation, we need to look at the polynomial form of quadratic functions. We can see this transformation in other forms, but the polynomial form is the easiest. In the polynomial form, we have y equals ax squared plus bx plus c, and it's the a that we're interested in for this transformation. If a becomes smaller, then the parabola will become wider, and you can see that here when a is a half compared to 1 in this case. And if a becomes bigger, then the parabola will be narrower, and you can see that here when comparing 2 to 1. The next transformation is a reflection. And for a reflection, again, we can look at the polynomial form, and looking at a, it depends on the sign of a. So if a is positive, greater than 0, then the vertex will be a minimum, like in this case. And we said that these parabolas are concave up. If a is negative, then the vertex is a maximum, and these parabolas are concave down. Next, we'll look at translations, and to see translations easily, we need to put the quadratic function into the turning point form, and we'll cover how to do that in another video. But the turning point form looks like this, and it's called the turning point form because h and k give the turning point of the parabola. So for vertical translations, we're looking at k. When k is positive, like in this blue scenario here, then the parabola will move up. So if k is 2, the parabola will move up to y equals 2. And so the turning point is at y equals 2. If k is negative, then the parabola will move down. So in this case, -3, the turning point is going to be at y equals -3. And so it's shifted down. In vertical translations, the axis of symmetry will stay the same, but the vertex will shift up or down. For horizontal translations, we're still going to look at the turning point form, but in this case, we're interested in h. Now, for h, it's a little bit trickier, but we'll start by looking at the red one. When h is positive, the parabola moves right. So if this here is x minus h all squared, then the negative is still there. So that means h must be 3 in this case. And so it's shifted 3 units to the right. In this one, if we're looking at x minus h all squared, then the negative has gone. That means that it needed to be h is equal to -2 in order for this to become a positive. And so when h is a negative, the parabola will shift to the left. So it's moved 2 to the left in this case. In horizontal translations, the axis of symmetry and the vertex will both shift. So let's see if we can do an example now. Here we have y equals 2 outside of x minus 1 all squared plus 3. So it's already in turning point form. That means we can look at the turning point by finding h and k. And so h, here I can see we still have a negative, so that means h is going to be a positive 1, and k is going to be 3. So the turning point is 1, 3. That means the parabola, if we're comparing it to y equals x squared, has shifted 1 to the right and 3 up. Just going to put that turning point here. Now I can also see that there's a 2 in the front. So if we were comparing it to y equals x squared, then this parabola is going to be narrower than y equals x squared. And now before I can sketch, I need to look at the intercepts. So I'll start with the y-intercept. Y-intercept. So we're going to substitute x is equal to 0. So y is equal to 2, 0 minus 1 all squared plus 3. So y is equal to 2. This is going to become minus 1 all squared. And negative number squared will become positive. So we'll have y equals 2 times 1, which is just 2, plus 3. So y is equal to 5. So our y-intercept is going to be at y equals 5. And since the turning point is here above the x-axis, we're not going to have any x-intercepts. So I'm not going to worry about those for now. And now we can sketch the parabola and write the equation next to it. So we've got y equals 2x minus 1 all squared plus 3. Now the question may ask you to state the turning point or the axis of symmetry. The axis of symmetry in this case is just going to be where the turning point is. So this line here. So the axis of symmetry is going to be x equals 1. And the turning point I might just label here as 1, 3.